السلام عليكم دكتور.
Waalaikumsalam.
Finally, apa kabar? Sehat?
Baik. Sehat, Alhamdulillah. How are you?
Good, Alhamdulillah. Bagus, bagus.
It's good to see you.
Yes, for a long time. Wallahi, I miss my center and miss all my my lecturers, all my colleagues in UKM, especially in JKKB. Wallahi, really missing. Inshallah, soon coming.
Welcome.
Inshallah.
Thank you for attending, Doctor. Okay, the speaker is here. Hello, Prof. Eniya.
Hello.
Hello, Prof. How are
Yes.
you?
Hello. Assalamualaikum.
Waalaikumsalam, Prof. Thank you for joining us today this evening. Right? Yeah, okay. All good in Indonesia?
Invitation also. Yeah. Are
Yes.
you hear me clearly?
Yes, I can hear you. I can hear you.
Okay.
No
Yes,
problem for
it's
me.
good.
Okay.
Okay.
So, shall we start, Prof?
Yeah.
Okay. Right. I think to technicals, we will start now. Okay. So,
Fantastic.
welcome to everyone. Okay. My name is Mohamed. Okay. I'm from UKM-YSD, Chair for Sustainability, Universiti Kebangsaan, Malaysia, and I'll be your moderator today. Right. So before we start our webinar today, okay, thank you, Prof. Eniya, for joining us. Okay. So these are some basic house rule. Okay, for all. To all participants, please keep your mic on mute at all the time. Okay. And then this webinar will be available on Zoom, and you can YC Chair for Sustainability's Facebook page as well. Okay. So please feel free to share this FB page to your friends and colleagues. Okay. The link for attendance will be given at the end of the session. Okay. So please wait until the end. Okay. If you want certificates or you want UKM backup for UKM staff. Question and answer session will be open at the end of the session. Okay, so the audience, okay, you can either choose. Okay, first, you can we allow you to ask directly to Prof. Eniya. Okay, or you can write the questions on the chat session. Okay, I'll read it for you at the end of the session. Or if you are listening with us from Facebook, okay, we will also collect the question from there as well. Okay. And we at the chair, we provide a digital background, okay, and it will be shared on our chat session, okay. So please feel free to download a digital background, okay, and we will use it during our photo session at the end, okay. And for more information, okay, for our programs, okay, under UKM-YSD Chair for Sustainability, okay, please feel free to follow our social media on Facebook and Instagram and also on Twitter as well, right? So Prof. Eniya, okay, we will start our talk, okay. So please allow me to welcome, okay, Prof. Eniya, okay, from Badan Riset dan Inovasi Nasional Indonesia. Prof, welcome to our webinar today, right? So on behalf of the organizer, okay, I welcome everyone to our monthly webinar, okay, organized by UKM-YSD Chair for Sustainability, Faculty of Engineering and Built Environment, UKM. My name is Dr. Mohamed. Okay, I'm the manager of UKM-YSD Chair, okay, and will be moderating to this webinar. This webinar is jointly organized by the Department of Chemical and Process Engineering, JKKP, and by Research Center for Sustainable Process Technology, CESPRO, Malaysia Academic Research on Palm Oil Sustainability, ALPOS, and also supported by Clean Energy Special Interest Group, ICANE, and Badan Riset dan Inovasi Nasional BRIN Indonesia. So please allow me, okay, a brief introduction for our speaker today. Okay, our special speaker today actually is Professor Dr. Engineer Eniya Listiani Dewi from BRIN Indonesia. Prof. Eniya is a very passionate supporter of a hydrogen society. She is involved for more than 20 years in developing various technology, advancing the use of hydrogen in our society. She completed her bachelor, master, and PhD from prestigious University Waseda from Japan, Prof? Okay.
Yeah.
So she is also the founder and chairperson of Indonesia Fuel Cell and Hydrogen Technology Association and the board director of International Association of Hydrogen Energy. Over the years of service, she has published more than 200 publications and numerous awards for her excellence in research and also community engagement. So indeed, a very versatile researcher. Without further ado, I would like to invite Prof. Eniya, to share with us on the hydrogen landscape in Indonesia. Prof, the floor is yours. So you can share your slides and the talk with our speaker, with our audience. Yeah, Prof.
Okay, thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you so much to inviting me for Dr. Mohamed, and also for all of the student and participant here from Malaysia, especially from UKM. I'm really happy to hear with you, and I will share a little bit progress in Indonesia, especially for the hydrogen and fuel cells technology that we are doing now. So I will start my slide here. I hope you can see that one. Okay.
Yeah, it's good, Prof. Yeah.
Yeah.
Okay. Good.
Dr. Mohamed give me an interesting topic here, emphasizing the hydrogen movements for island especially. Do you know the location of this background? So this is very very nice place. Hope you can see Indonesia, but you must fly to Bali at first, and then one flight from Bali, but just 30 minutes. Then you can reach the Labuan Bajo. This is now a famous tourist destination, and you can climb this small mountain, and you can see the different colors of the ocean. It is very nice. I maybe in the next 2 years I will invite the chemistry community to be here, because there is so much interesting location at here also. And you can see the Komodo. This near the Komodo Islands.
Komodo Island.
Okay. So Dr. Mohamed is already giving the introduction that I'm graduated from Waseda University, and then now I'm the professor research at BRIN. Before I was the deputy chairperson from BPPT. It's just like an application of technology agency, and then we now to be just one research agency in Indonesia right now, but it's a very big one. It's called Badan Riset Inovasi Nasional, that we call BRIN now, and we have 15,000 researchers. So it is a very big one. So talking about the hydrogen journey, I will start with the our collaboration with UKM. So this is really honored to know the Professor Wan Ramli Wan Daud. Maybe you know him so well.
Yes.
So he is the first partner of ours in the terms of fuel cells and hydrogen technology. So after I graduate from Japan, then I back to my agency, and then starting to study the fuel cells technology, and then now move to the more to the hydrogen one. So in 2007, I make a first seminar for the fuel cells technology. We inviting the personnel from NADO and person from especially from Japan. And then the Honda also support us. And then I especially invite the person from Malaysia at that time, Prof. Wan Ramli, and this professor from Singapore. Then also now the big professor in Kyushu University, maybe you know him also. He is I'm sorry, I forgot the name. Sasaki Sensei. Now, and then we have so many collaboration with Malaysia. At that time, we showing the fuel cells prototyping, and then we make firstly the motorcycle of hydrogen. I think Malaysia have a move the same time, and then now we flew every we oftenly make a joint international collaboration. And then before COVID, I met Professor Wan Ramli, and then we make a signing MOU between Indonesia fuel cells and hydrogen energy, and also Malaysia have Malaysia Association of Hydrogen Energy. This is a really nice place to know. And then I visit also the Institute of Fuel Cell in UKM in your facility. And then last year I met Dr. Edi Majlan, yeah, and then Professor Arshad from UTM. I think it's a big professor also in the terms of hydrogen, right?
Yeah.
Yeah, it is very good to know it. And I hope students also can join our annual meeting in this year. In September, yeah. In September, we will have also the International Conference of Fuel Cell and Hydrogen Energy. And hopefully, our link is already noted by International of Hydrogen Association. Then they always publish the Q1 journal, IGHE. Yeah, so we can make a stronger movement between Indonesia and Malaysia, and hopefully this will continue again and again.
Yes.
So yeah, it is my voice is clear, not
okay, yeah,
interrupt. Okay, sure. And the last at the end of the year of last year, we establishing the Hydrogen Day, and we have a community right here. Now our association also have a member from Toyota, from Yamaha, from PLN, and also from Pertamina. There's several industry now join us, not only the university and then research institute, but we now, our community going bigger, including the industry. So getting into the next topic, you already know that we are facing up the climate change, and some of you maybe ever go landing to Jakarta, and you will see it's a little bit, this is not cloudy, but this is the pollutant of the air, because before COVID we have no view like here, but now it's going back to be like a cloud again. This is increase because of the transportation. And last year, I'm also joining the research and development of the G20 member states. And one of the Professor Christopher Hebling here told us that the CO2 increase and then the temperature increase start from 18,000 year. In the year of 18,000 start, and then the global temperature is increased right now, comparing to almost to a century. And then you know, the atmospheric CO2 concentration also increase. So this is the fact that we are facing up the climate change. So maybe you know that Indonesia will move to the new capital right here in Kalimantan, yeah, and we will move starting from this year, I think, or the next year. But now government is pushing the development around there. So I think this is a new opportunity for us also to make a renewable energy from even a hydro, or maybe we have a palm and so on. And I think you know a little bit Indonesia language.
Sumber energinya adalah berasal dari renewable energy.
Our president wants the renewable energy in this new capital.
Kemudian 80% transportasinya adalah transportasi umum, autonomous vehicle, tanpa awak dan tanpa supir. Jadi yang kita hargai di sana adalah pejalan kaki. Yang kita hargai di sana adalah orang yang senang naik sepeda. 10 minutes city. Jarak tempuh kemana-mana itu ada dalam 10 menit. Sekali lagi, inilah showcase transformasi Indonesia. Showcase perubahan peradaban Indonesia. Dan budaya kerja yang ingin kita bangun di IKN Nusantara adalah budaya kerja produktif.
Okay, that's the new capital that called Nusantara, and our hope is so much renewable energy at there. So hopefully the government realizing this plan to make a new capital. Yeah, now in Indonesia talking about the investment, but I'm sure that this new capital also will be a good opportunity for us, for young generation, to make a new movement, yeah, new transformation. So talking about the climate, because our new capital have a vision of the renewable energy, so the Indonesia have a commitment. I think Malaysia have also the target to reduce GHG emission right here. We committed that Indonesia will make a carbon neutral at 2060, or maybe all over the world claim to be 2050, but Indonesia is a little bit 10 years later, but if there is an international commitment and international contribution, so we want more sooner. And then what we going to do with this this carbon neutral, because we must reduce the emission, so we accelerate the renewable development also, and then much moving on the low emission, and also going to the free carbon society in the future. So, you know, the potential of the renewable energy in Indonesia is really quite big. And then this, you can see the number, the solar potential number is 3,000 gigawatt, but now just only installed around 200 and not more than 300 megawatt. So the potential is really big for the solar. And also with the hydro, we have 95 gigawatt, but the installed capacity just only 6,000 mega. And so with the others renewable, like wind, geothermal, and also tidal. We're not starting the tidal because this costs really high. I think we focusing on this 5 renewable energy is enough for us to realizing the carbon neutral. But if we have a good investment on the tidal, why not? So the transition toward the sustainable energy, we are now moving step by step. As a BRIN, as a Badan Riset Inovasi Nasional, we suggest the government to do the biofuel program. You know, I think in Malaysia it's already like B20, I think, yeah. Now Indonesia accelerate to be B30, and then this year would be B40. So this is a new movement of our ministry here, already talking about B40, and then now they prepare the implementation for the passenger car here. And this is already have a road test starting last year. And then this year, maybe in the end of March, would be result from the B40. I think there is no such kind of barrier to make an implementation of the B40. So the SNI, the standard of national Indonesia standard, and we make the new standard for here. And of course, the performance test for the train, the genses, heavy duty vehicle, and also in maritime, we have a performance test right now. And then the other movement is like a co-firing. Now we have many power plant that being operated by PLN. This is a national state-owned company of electricity. PLN have a 60% of coal right now, and they make 20 until 10 and until 20% of biomass have been co-firing in the power plant. So the other one is refuse derived fuel. This is the process from the waste to fuel, how to make a new fuel and briquettes to make co-firing also at here. And then we have also the dieselization program. We make the study of also the implementation of even fuel cells, not only the dieselization with the geothermal, with the biogas or biomass, but now we consider about the fuel cells. And of course, carbon capture storage, this is not new things in refinery. We already have a carbon capture storage facility in the refinery. And then this CCS has also been will implement in the power plant also. And you know, the electric vehicle also have a very big portion in Indonesia. I will talk you a little bit more after this. And about the PV, we are consider about the PV rooftop, floating PV, and also the e-mobility, smart grid and area. And after the G20 meeting last year, Indonesia have accelerated the blue and green hydrogen facility to supply the, especially for petrochemicals industry and another industry, and also start to think about the transportation application. So this is the example of the biogas facility. I think it is similar with the Malaysia, because we make biomethane from the waste of POME, this palm meal oil effluent. It's like a liquid waste from the palm industry. Now we put the biogas technology at the industry in Sumatra Island. This is the example that those industry already make a new carbon credit to them to make a new facility for the benefit of the biogas that implemented on this area. And also, this is the few example of the electric vehicle movement in Indonesia. You can see the conversion, the program of how to make a conversion from the conventional vehicle to the electric vehicle. So the aim of this program is to make multifunction economy. We can make a new mechanical here, new electric motor industry, and also the battery industry, and also the scheme of the swap station and so on. So talking about the emission effect, there is more than 3.8 million tons of CO2 will be reduced in a year. So this is an ongoing program. And I will show you my activity also since 2018. I'm accelerate the electric vehicle. This is me. I'm riding the electric vehicle. Now it's common in Indonesia, but want to make it more people using the electric vehicle. So the government now give the special funding, not special funding, it's incentive to person that buy the electric vehicle. I don't know right now in Malaysia, maybe you can tell me later on. So Jokowi have commitment to make decarbonization in Indonesia. So we will achieve 2060. But now in the research community, we're talking about the percentage of the renewable energy have already implemented. It's still 14%. So it should be more aggressive acceleration of the implementing of renewable energy. So the step of our president movement is to stop the coal power plant, and then would introducing nuclear on grid in 2049, and also make a hydrogen society in the future. And of course, in between, from now until carbon neutral year, we must thinking about the energy transition strategic scenario. And you know, Indonesia have a big islands, have a lot of islands. So the main problem here is how to distribute the energy, and all of the people in the remote area in the village can have the accessibility to the energy in a good way. So there is no such increasing payment. They know about the technology, so they can maintain. And also there is a innovative finance to get the funding. And now we're talking about the how international assistance can be contribute on our society also. And then the next one, we know the technology must be implemented as well as such as transfer technology and so on. And then the point is how to make people also contribute with the energy. So they have a new economy during the energy transition in Indonesia. So the answer could be the hydrogen. So we're not only talking about just hydrogen right now. So not just only me. Starting 20 years ago, it's like only me that many aggressive progressive movement now in Indonesia. So I think I will skip this because you know already the hydrogen is abundant materials in the universe, but now we must get the hydrogen from the other resources. Even there is a natural hydrogen just coming out from the earth. The funding, it was found in the Brazil and in Chile. There is a natural hydrogen, but there is not a big gas coming out with the hydrogen in the pure. We must get the hydrogen from the other resources that we call a second energy. So talking about the hydrogen production method here, I introduced you about the fossil fuel methods, and then there is a renewable source method. We are now talking about this area, yeah. So how we can make a biomass process to get the hydrogen, even in the route of biotechnological method and in the route of the thermochemical method. And you know about the water splitting, so we can got the hydrogen and oxygen from the water. So another this area is already happened now in all of the world. And all over the world, and then all over the industry, they already have fossil fuel resources to make the hydrogen. So I think all of you know that already have the industry to have hydrogen, and in the implementation side, you know that the hydrogen is being used for the pharmaceutical application, and also for the synthetic fuel, and to upgrading biofuel like a biodiesel, just I talked before, a B40, the biodiesel, it is also need the hydrogen to make upgrading of the biofuel. And then of course in ammonia industry, in fertilizer industry, we need the hydrogen, and this is consume so much hydrogen even in Indonesia. This is the biggest one. And then the other is for chemicals industry. And that's the hydrogen that coming out from the coal, we call brown hydrogen, and then coming out from a gas, we call gray hydrogen, is the color of the hydrogen. And then if we capturing the CO2, we can got the blue hydrogen. And then if the hydrogen coming out from the reaction of the nuclear fission with the thermo or with the electrolyzer, we call pink hydrogen. And then the last one we call a green hydrogen. This is a green one is using the renewable resources like a photovoltaic, like a wind turbine, like a geothermal and others, and also the hydro, the water. So maybe you know also the process of the hydrogenation in the industry, such as if we make a disinfectant or we make a bleaching, we have a peroxide here, and then we have also I'm sorry. Okay, I continue. We have a hydrogenation process in the food processing industry, like to make a shortening or like make margarine. Well, and in Indonesia also, I think in Malaysia have to also, if we have a PVC industry, we have an excess hydrogen. This is especially we now trying to get the excess hydrogen from the industry, so we can calculate it and then collect it, how to make the utilization of that hydrogen. So from power plant also we have an excess hydrogen, because the power plant only use the hydrogen for the cooling. And then of course waste from the heat of the steelwork, we can use it also as a cogeneration. And then just several excess from the gas industry. So thinking about the infrastructure and the ecosystem, we must putting this opportunity, many opportunity around the area, so we can think about how we can make the utilization of that hydrogen. And about the hydrogen value chain, I already mentioned you about the how we can produce the hydrogen. And then the next one, how we can distribute and can storage the hydrogen and then make a utilization of it. So this we can make a combustion, we can go with the turbine, and also the transportation and chemicals. So in the term of the distribution, we must think about the area and how we can produce from what. So which one would be the next line to make in some area, because Indonesia is island. So we must think several steps here to implement it. If we can implement it in Sumatra Island, different from the Sulawesi Island. So I will see you the differences after here. We can make from the coal and so on. You can see this, but the important things is the pipeline. So the pipeline regulation also have a big problem now in Indonesia because we not yet specific regulation. So I will share you my dream. My dream is how to make the hydrogen city over here. And then until now, I still cannot realizing my dream, but I running with my dream. It's make me so passionate in this society. This is our example. I can give you the example of how we can make the hydrogen city. This is the picture of 2010 that Japan already implemented the fuel cell on the household. So they also supply with the hydrogen from the steel industry around that, around this community, and this covering with the university. I ever go to Bangi, yeah, I see that location also similarly like this. This is a there is a well, not capital area, but surrounding by university, and then a good local government, and so the opportunity of the industry also can be created over there. So this is one area that covering all of our things. So the hydrogen could be started here. The next one is this is the I visit in 2007, I think, in Tokyo. I visit the Tokyo Gas, and they created the infrastructure. Firstly, they created the hydrogen station. I'm already heard about the hydrogen station in Sarawak, and I want to go there to see your facility. I have maybe in this year I will go to see that. And you know, in Korea also the same things. They make the hydrogen pipe, and then they make some of ecosystem around the area. That putting the charging station, and then how to produce the hydrogen maybe from a solar panel, and also they starting the use of this hydrogen in several locations. And many of them using the fuel cells in the household or residential application. I think this is for backup power, and several around here using the on the smart farm, they're using the fuel cells also. So this is the example of the hydrogen city. It is in Korea. It's just built in last year. So I think that would be interesting if well, especially Indonesia can have it in Kalimantan or the others. Now, I'm showing you about the hydrogen challenge in Indonesia, because Dr. Mohamed gave me a title about the islands. So I think about the opportunity of the renewable energy in many islands here. The biggest one is, of course, Java. The biggest consumption of the energy is Java, and we have geothermal, we have coal. Now we have coal power plant. So much electricity that come from coal right now in Java. We have the excess electricity also in Java. Bali is right here, and we have excess electricity around here, but supplied by a coal. And then now PLN thinking about how to use the excess one. And if we talk about the Sumatra Islands, we have a hydro, we have a geothermal also, but I will not suggest it if you putting the solar right over here, because the solar intensity is much bigger in the East Indonesia. And talking about the Sulawesi Island, we have several. We have the opportunity of wind also, and then we have a solar potential of solar, and we have geothermal and a little bit hydro. And then in Kalimantan Island, there is no geothermal, but we have a big hydro at here. It's Sungai Kayan. It's 9 gigawatt potential of the hydro in here that would be supplied to the new capital. So another island is the big one is Papua. We have a big river also at here. This is Membramo River. So the opportunity of the renewable energy from hydro would be, I think, more than 20 gigawatt, I think, could be supplied from here. And then the possibility of a wind turbine. And around here, we have a solar. Now, there is a several project, the hydrogen at here. They will make the green hydrogen from here. This is, they will setting up the solar cell in 30 megawatt and will produce the hydrogen and convert it to the power of using the fuel cells and will supply on grid. So this is the green hydrogen project. At here, there is a green hydrogen project also doing by Pertamina that's coming up from geothermal. And then we have several hydrogen and ammonia, green ammonia here from the more than 6 program now making the green hydrogen and ammonia at here. And the others also from the Kalimantan Island. But all of this is the on the feasibility study right now. So I'm thinking about if this Sumatra Island would be the producer of the hydrogen, we can have the hydrogen highway over here. And then, of course, the hydropower hydrogen production will be supplied in the Kalimantan, and here we can get the green electricity. So that is the challenge in Indonesia, and you already know about the conversion of the electrolyzer to make the hydrogen. This is just a scheme of the green hydrogen. You must think about the size of the solar cell, and you must think about the size of the electrolyzer, and so on. So I will show you our activity in BRIN right now. We have 100 kilowatt of fuel cells, 100 kilowatt of solar panel at the rooftop. And then from here, we want to make a green hydrogen. But now our prototype is only 1 kilowatt of photovoltaic to make the hydrogen just using the, we make a electrolyzer, PEM electrolyzer, and also the solid oxide electrolyzer have been done in our research. And then this is the example of our green hydrogen prototyping. Not yet get from the 100 kilowatt, but we now having 2 kilowatts, and we try to make it to make the scale up of this prototype in the next year. And we try to implement it, the vertical wind turbine from our ex-host laboratory. And then the electricity from here going to the electrolyzer here. And then we storage the hydrogen that coming up from the electrolyzer. And then want to supply the hydrogen to be here and be using the fuel cells at here. This is the concept of green hydrogen prototyping. Next to the biotype of the hydrogen, we already have a scheme project, several projects here that we produce the biohydrogen. I think this UKM also have a big program of the biohydrogen. We have a really close relation also with the UKM in this. Our biohydrogen prototyping is located also at BRIN Serpong area. We're trying to make microbes that collect from the sludge over the pome. The waste location from the palm industry, and we have NDH 45 microbes that we growing to make a hydrogen rich, and then want to scaling up until 1 meter cubic of sludge, and then we want to create more hydrogen gas at here. And the next one we will try, it's already starting since 2009, and now we're getting this step. at 1 meter cubic. And then we will, the next one, we will move to the 100, but not yet get the funding for this. So we try to reach this program. This is the special treatment that we use biofilter right here to make rich the hydrogen gas that coming up from bioreactor here. So this is our new program here. We have several researchers that doing the biohydrogen that's coming up from any waste, cocoa, sugary matter waste, and of course pome and sagu, and also algae. We have also want to purify this gas, and then in the plant we will make a hydrogen storage to this biohydrogen, and want to supply the gas engine generator. So that's our planning, and from the gas engine generator we can get the electricity, and we can supply another things from there. So this is our new topic also on photocatalysis hydrogen production, that doing with the collaboration with the University of Indonesia. We have several students that doing the photocatalysis at here. And the interesting things is we use the ammonia wastewater, and in the next one we use the antibiotic wastewater. So well, you can see in the journal the production from here. We got the several electrodes to combine, to compare, and then we see the hydrogen production over here. And now we're trying to get the hydrogen production from pharmaceutical waste. This is the antibiotic waste, and we will use the electrocoagulation photocatalysis here. And we have ongoing doctoral candidate at here to make various of pollutant of pharmaceutical waste. So the next one, I will show you the our activity on fuel cells and hydrogen application. Talking about the green hydrogen, you already know that if we produce hydrogen, we can use in the many things, in the transportation, in the industry, and also the electrical grid. And also the next one, talking about the carbon recycle, we must think about the ammonia also, because we need the carbon, or we want to make a methanol, make methane, and so on. We can capturing the CO2, and then we convert it to another things of chemicals. So this is the surrounding the ammonia energy will be the answer also, how we can use the CO2 to react with the gas, and then got the other chemicals. I think this study have been already done by several researchers, but now industrial area have moving, talking about the ammonia energy. We have a big fertilizer industry in Indonesia, and we're thinking about how to reduce the CO2 emission that coming up from the process. So in to lowering the emission, not only fertilizer industry, PLN also doing the co-firing. They usually going doing the co-firing with biomass, but in last year they're starting to use hydrogen and ammonia to do the co-firing in power plant. So you can see this is the burning of the power plant. There is no such of not really in the step of the experiment. They now successfully to be 2% of ammonia combined with coal. So the problem here is how we can reduce the NOx, the nickel grain oxide. The NOx level is a little bit higher, so it must be lower than the NOx if we do co-firing using the ammonia in the power plant. This is just a start in October, and hopefully it can reach more than 2%. Well, I'm not still about, I'm not talking about the finance here. So we just only talking about how to reduce the emission. So trying to combine between coal and ammonia as the first step that we reduce the emission. So about the hydrogen utilization, you know already the type of the fuel cells. We can we can make a utilization of the fuel cells and really disparate industry here. In the small scale, we can see the drone, forklift, and then in the up to 5, we can see the household, and more than 10 kilowatt, we can see the passenger car, and also well, almost 100, we can see the bus, and also the others. In the maybe in the this year, there is an application of the airplane that using the hydrogen. This is to be very big issues also in the aviation industry, because have the Airbus and also the Zero Avia have successfully flying the hydrogen plant. So I think the use of the hydrogen and the airspace and the aviation industry, it shows that the hydrogen is safe, not like previous image that the hydrogen can be explode everywhere, but we can see that if we use the hydrogen, there is no problem of the safety if we concern about the utilization and have a regulation to make the hydrogen application in this area. And you know, in long term, the utilization of hydrogen would be the highest in the transportation area. Now we talking about the gas industry for the industrial application, but in the long term, in 2040 and 50, we will see that transportation would be the huge demand of the hydrogen. And of course, what is the key technology that we must concern? I think this academician or more in the industry must think about the key technology of that. The key technology is how to make the electrolyzer and how to make the fuel cells. Because if we're talking about the green hydrogen, we're talking about the electrolyzer. If we're talking about the transportation, we need the fuel cells. So I think this ecosystem should be considered. You must think about all of the ecosystem here, and thinking about in the academic area, we must thinking about the key technology here. This is I think you are all chemists, so you can see that the hydrogen and oxygen can be react in the electrochemical processes and make electricity that's called fuel cells. And you can see the electrolyzer is how to split the water into the hydrogen and oxygen. So in UKM, in Institute of Fuel Cell, there is so much acceleration of the fuel cells development, yeah, including membrane and including electrolyte and so on, electrode catalyst and so on. So you can see that the reaction is around the how to control the electron transfer in the inside of the fuel cells. This is the important things if we want to know about the more specific reaction in the fuel cells. Well, the last one I will show you the our journey of the fuel cells and hydrogen development. I think this has happened also in UKM. So we have the same things to do. We accelerate the membrane development and also catalyst, and we have also several things to make the fuel cells stack. And from now we not only doing the PEM fuel cell, but doing the solid oxide fuel cells, and we doing how to produce the hydrogen from bio and from also the water. And this is, I will skip off this. This is the manufacture of the fuel cells that we are do. I think you have see this one also. And the interesting things in to make the fuel cells, how we can manage the water consumption and how we can manage the gas inside the fuel cells, and how we can treat the catalyst loading inside the fuel cells. This is the interesting things, and they need know-how to make a stack of the fuel cells. This is very long time ago. This is my photo since 2006. I'm doing this, and also at that time, I think Professor Van Ramli and several doctors in UKM to start this also. So we have close collaboration at here. And now I'm talking about the industry. I'm pushing the industry and local industry in Indonesia to make a component at here. Because in Indonesia, we have automatic industry, automobile industry. So they supply many compartment to the Toyota, to Honda, to several mobile, and I think they can make the fuel cells from the beginning. So now we're pushing the industry to get know-how at here. Now BRIN also doing the several things joining with the industry, and this is our collaboration with the University of Parahyangan. We have a nano road array of the catalyst that growing in the carbon paper. And then we have several development on the carbon papers also. We have several scientists at here. And of course, we joining with the UKM with the solid oxide fuel cells. This is an interesting thing also. They're doing by Dr. Jarod, Professor Jarod here. And they have a collaboration with local industry at Timah, Indonesia. And they have zirconia, local zirconia, and successfully to make a solid oxide fuel cells. And this is, I want to show you about the application of the fuel cells in motorcycle. This is have been done with the with team of the UKM also. Yeah, this I will show you the same things. I'm sorry, this is in Indonesia.
Ini adalah bokar yang kita modif dengan fotovoltaik dan fuel cell. Fuel cell-nya sebesar 2,5 kilowatt. Dikontrol, lalu gas hidrogen ada di bangku depan. Yang ini fuel cell tanpa PV, fuel cell dengan kapasitas 1 kilowatt. Ini ada kontrolnya, gasnya ada di sini. Ini adalah dua jenis prototipe kendaraan hidrogen yang
okay, that's our activity, and since pandemic, yeah, since last pandemic, or in this 3 years, we make the fuel cells application in motorcycle, and we convert the electric vehicle at here and to make the hydrogen vehicle. We make several. This is our team from the electronic guys, from the mechanical guys, and so on. So this is the first motorcycle of hydrogen since 2009. You can see this it still happen. It's still being right now. So I can tell you that fuel cells have a long durability. It's already almost 13 years. So I think the fuel cell itself have so much higher durability comparing to the battery. This is our prototype also with the 1 kilowatt that we mentioned before. And then this is the golf cart. Why I put the photovoltaic right here? Because the student want to know about how to produce the renewable electricity from the photovoltaic coming to the battery, and then we can do the same thing with the fuel cells from the gas going to the battery. So the combination this we can make several tests right here. So now this is the recent product of our team led by Dr. Hamid. They're making the refueling station, the mobile refueling station, to supply the mini hydrogen right here. And we will produce the electricity from 100 kilowatt of solar cell, and we will put the electrolyzer, and then we can storage the hydrogen and supply to the prototype of vehicle here. So talking about this is the conclusion of our would be our my talk. The price of the hydrogen now, the highest one is the green one, and the lowest one now we have it in the industry is the gray hydrogen, and then the brown hydrogen. It's around $1 until $2, but in the green hydrogen we still have $4 until $6. Maybe in Japan, I asking to the NEDO, they produce the green hydrogen for $10 per kilogram of the hydrogen. So it's still not really usable, but I think the price will be going down. And this is just I will skip this. Wait. I will talking to you about the hydrogen price and on the road. In Japan, there is a regulation that the hydrogen price should now is $10, about 1,200 yen per kilogram. So if we going to the hydrogen filling station, this is located at near Tokyo Tower. If you go to Japan or you go to another country, you can see it freely. So they selling the hydrogen price still in $10 per kilogram, around $10 per kilogram. This is with tax, it would be 1,200 yen per kilogram. So this is the picture. So I think Malaysia and Indonesia should make a national hydrogen strategy, hydrogen roadmap, so we can invite the investor to our country to make the society much more bigger, more better. No, there is no carbon around us, so we can have a good lifestyle here. And okay, this is the hydrogen roadmap in Indonesia, but not roadmap, not really roadmap, but this is just a study of the Ministry of Energy that Indonesia would be a very huge demand of green hydrogen also in the next carbon neutral year in 2060. So we can see the increase of the hydrogen is start on the 2030 and then will increase significantly in 2040. It means that the hydrogen price could be more cheaper around 2040. So we can see that. Okay, I think if I have still 1 minute, Dr. Mohamed?
Can, Prof. Can. No
Okay,
problem.
okay,
No problem.
okay. Just show you the implementation of the fuel cells. It's already has been using in Indonesia, but used as the backup power of fuels power station, the backup power of BTS station. This they already have the genset, but they switch to the fuel cells. So we can see that already now it's more than 800 BTS. This is in the 2012. There is a 472 BTS that supply by hydrogen. So they use 5 kilowatt of fuel cells at here. This is the fuel cells, and beside that you can see the hydrogen tank over here. So this is have been implemented in the several islands of Indonesia, all over the Indonesia, and now would be not only 800, it's already 1,000 unit has been installed as a backup power. This is the showing the photo of the implementation of the fuel cells. This is in the rooftop because fuel cells are very silent. No, not like a genset that shaking the compartment, but it's very silent because we only have the electrochemical reaction inside, and it can be used all over the building. And this is the unique things that the company is putting the fuel cells in the remote area. This is several struggling. They struggling to deliver the hydrogen. Firstly, they deliver the gas, but in about 5 years later, they are starting to deliver the methanol combined with water, the methanol water. It's called Hydro Plus, and it's much more easy to deliver. But the fuel cells compartment have some added steam reforming unit to embed the fuel cells. So the hydrogen, the methanol, the water containing methanol coming to the steam reforming, and then go to the fuel cells and go to the electricity. So I will show you, this is the unique study that just have been done in the last month. We calculated in the specific island. This is in remote area. It's in East Indonesia. It's called Medang Islands. You know the profile of the electricity here. Now they have photovoltaic, and they have a battery, and they have a genset here, and the supply, the profile of the electricity that's supplied by photovoltaic is right here in the green one. Yeah. And you can see the genset start doing the activity from the night until the morning. This is the red one. And you know, this is the excess of the power. Okay. And if we know the excess of the power, because not so much electricity that need in the daytime, we can use this electricity go to the electrolyzer. That's why we calculated the implementation of the electrolyzer and fuel cell in this island. And we collecting the implementation of this fuel cell. You can see the graphic here. This is the blue one, is the time of the fuel cells work. And then you can see this is the excess electricity from the daytime. You can go to the to use this to electrolyzer. So you can see the red one. This is the supply electricity that we calculated right now. So hopefully this would be to expand your imagination that we can use the fuel cells even in the small scale. But but we still have a demand of the diesel here. Still just a little bit. Now, yeah, that's the last thing that I want to show you. I want to share you about the study, and this would be implemented in this remote area. So finally, I will invite also all of the students to join our laboratory, to coming up here to join our hydrogen research group. And we hopefully you can visit our website also. It's IFE or ID. And I will really lovely to have your question in this event. Thank you so much. This is our upcoming event in Hydrogen Summit in June. Please come to Indonesia for this. Thank you so much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you so much, Prof. Eniya, for your interesting talk. Okay, and then just to update you, roughly we have about like 130 participants on the Zoom, and about 30 more on the Facebook. Okay, and there are some questions. So are you ready for the questions, Prof?
Sure, thank you. I'm
sure.
happy to
Okay.
Yeah.
Okay, so let me read a few things. Okay, there's a first question from Miss Hanim. Okay, she asked about the costing actually, because just now you share some of the data on the price. Okay, is it only from the other country, or is there any studies done based on the scenario in Indonesia?
Oh yes. The price is just only the study from the journal and the others country and Japan price. So not yet in Indonesia, but now we also calculated the like I show you the price of the system that using the fuel cells, and we make the hydrogen. It could be cost around well around still $6 for the green one, $6 until $8 for the green one, but we have calculated in Indonesia, if we use the price of the electricity of hydropower, it would only cost below than $2 per kilogram of the hydrogen. So the lowest one, the lowest price of the hydrogen is coming up from the hydropower. That's our calculation at here. This is the Indonesia price. I think I have it, but I skipped the answer of your question.
It's okay,
I will share because I skip it. That's why you answer you questioning me. So this is the example of our calculation. This is our calculation in Indonesia. We have, if we do the hydrogen production from the geothermal, would be cost around $5 per kilogram. And then if we, now the hydrogen price from the coal is around 3. It's around 3 until 4. This is the price of the hydrogen, the hydrogen business right now in Indonesia. It's the coal, from the coal. But in hydro, you can see $1.5 per kilogram of the hydrogen. And this is the calculation of our study in how to use the excess power in Java. We have the excess power in Java Island, but it still come from coal. And then we calculated the price of the hydrogen would be 3.5 kilogram per kilogram hydrogen. Sorry, per kilogram hydrogen. But if we have a incentive with a innovative incentive of energy transition funding, we can reduce $1 of that price. Well, it's around that price.
Okay, Prof. So thank you. Okay, there's this question from all over from France. Okay, there's Mr. Imama. Okay, he's working in the automotive industry. Okay, according to him, now the automotive industry is moving towards more on EV. Okay, and even though they claim the EV actually is green, but it's not truly green because of the usage of lithium in the battery system. So his question is really possible for hydrogen to be truly green for automotive industry?
It's a good question because it's difficult to answer. But as you know, as you mentioned also about the lithium and also the green hydrogen still have a battery. So we still depends on battery. We still depends on solar cell, solar panel. And if we're talking about the circular economy, this is not really green. That's why on the World Hydrogen Conference last year, we all over the researchers now talking about the life cycle assessment. So it is really new, but I think I can share you some things. This is really important that we now talking about the life cycle assessment, because many of the researchers told us that I'm sorry, that not the green hydrogen is not really green than the blue one. So and even with the gray one. So we must thinking about all of the life cycle assessment. So we will many researchers now is calculating how much we reduce the CO2. Not talking about the green one or the blue one, no, but they talking about how much they can reduce the CO2. So as you know, lithium is not so green. I do agree with that opinion also. In the term of circular economy, that's why many researchers also told us that there is some research, and need some research on life cycle assessment. And I'm glad that I'm now joining the task force of the hydrogen that talking about the life cycle assessment around the G20 members. And we're talking about the how to recycle it. And the basic opinion is the green is not really green than the gray, even the gray one. So this is still undergoing discussion. But don't worry, this is so much opinion on that also, because battery guys told us that it could be recycled. Yeah, there are so many way to recycle also the lithium battery. Our team members also doing that the recycle things. So I think I hopefully the circular economy is being done in the next several years. Yeah, hopefully.
Hopefully, yes, Prof.
So
okay,
the green
Prof,
would be the really green.
We are moving towards the true green. Okay, okay, Prof. There's another question. Okay, from Mr. Ekmal. He's from Tabung Haji Plantations. Okay, and I think he's more interested in the application of a fuel cell in a palm oil plantation, but especially for heavy vehicle. So, is there any example of a fuel cell application for heavy vehicles, maybe like a tractor or like a forklift, all this thing? Yeah.
There is two company in Indonesia right now. It's called Yamaha and Komatsu want to make a forklift of fuel cells. But now they do the study with the BRIN right now. And they will, but the location of how they use the forklift is inside the warehouse. So there is no barrier to make the forklift of the fuel cells. Just only need 2 kilowatt of fuel cells until 5 kilowatt of fuel cells, and then you can got the forklift. That's an ongoing project with inside the Yamaha industry. We have members also in our society. There is a movement about the how to make a towing, not only forklift but towing car. It's some kind of motor that doing in the logistic system. And the heavy duty vehicle, it would be start with Pertamina and Marubeni will start in the port terminal. They will use the hydrogen truck, but now still under the pre-feasibility study. Next year would be the feasibility study. Now, I don't know. It will use the fuel cells inside the truck vehicle, and the location, the road. I think it's not really off-road, but it's it's a flat road. But still, the next 2 years on, or well, the fastest one is next year. I don't know. In Malaysia, is there already have a truck or have
not truck yet, but we have a real car, okay, developed by the Fuel Cell Institute, okay, and there is, I know there's some work done in India as well. They're working on the bus for all these things. Yeah. Okay. So moving to the next question, Prof. Okay. So this question actually from Prof. Puan Yatim. Okay. She's from the School of Business in UKM. So her question is, okay, what are the immediate challenges in adopting hydrogen? Is it economics, finance, or policies? What stop that we don't take hydrogen now?
I think the policy is it's a goodwill. The government now have a goodwill because they want to reduce the emission, but the barrier is a finance. It's I think I'm also try to socialize that it should be an innovative funding for the energy transition. And if we have an example to do it, so I think we can do it in the finance. Especially for hydrogen, we must think more longer. Not just we can produce the hydrogen, but we can store it, and then we can deliver it, and then still we can use it. So we must make the long way if we want to calculate it. I think the financial guy always asking me about the IRR, return investment, and then how to make a good ROI. That's the only question from the bankers. So I always want to answer it that hydrogen must go to the X. To the X, it means that we must go to the ammonia, we must go to the methanation, and there's several ways to do. Not only to produce hydrogen, how cost it, but we must calculate it in the next process of that. And the important things is in Indonesia, if we have a carbon market, the carbon price, because the carbon market now has been pending with the government, the carbon price only $2 until $5 per ton of CO2. I don't know in Malaysia, maybe more higher or what?
I'm not so sure the price. I'm not sure the price yet.
Yeah, because if we compare to the European Union, the carbon price would be $20 until $40 per ton of CO2. Now from Indonesia, the UNFCCC just calculated the carbon price from Indonesia only $2 until $5. So now have been stopped. We want more higher price of the carbon because we need higher investment to lowering the carbon, but the carbon price is not so big as the European. That's our question also, because if we have a carbon price, the hydrogen implementation, it would be more smooth. Oh, there is a chat. Oh, no,
Prof
100
Klassen
euro
is
per
here.
ton. It's a good price, really good price.
I think we can welcome Prof
Thank you,
Klassen.
Mr. Peter. There is a chat here.
Yeah, Prof Peter Klassen from Netherlands.
Yeah, from Indonesia, just only 5. No, it's not so good. If we have at least $40, the hydrogen implementation would be good.
Okay.
Thank you.
Prof Peter, do you want to say anything?
I answering your question or not?
I think Prof Peter, she on her mic. No, I couldn't hear Prof Peter now. Maybe some other time. Okay, allow me to move to another questions. Okay. There's a question. Okay, we can use hydrogen. Okay, in fuel cell and also in hydrogen combustion technology. So hydrogen combustion technology and also fuel cell. So your opinion on both of these technology?
The combustion. Well, if we combine the hydrogen with the natural gas, the most efficient combustion would be 30%, 30% of the hydrogen and 70% of methane. There's many gas engine is in a good efficiency. It's the combination about hydrogen and methane and 30 and 70. There is a 40 and 60, but not really a good one. And comparing to the combustion, now Toyota already mentioned that they have the combustion engine for the hydrogen to use in the passenger car. I'm really not know about the combustion, but I think the efficiency of the calorie, the energy that can be calculated, the fuel cells, it's 3 times more efficient than the combustion. But that's the theoretical things. I don't know if there is some innovation inside the engine. It could be more efficient. Hopefully it will be. And if the hydrogen combustion could be on the passenger car, that's much more efficient, practical to convert the fossil engine to the gas engine. But in the terms of the calorie burn and energy conversion, there is 3 times more higher with the fuel cells one. Personally, I more agree with doing with the fuel cells because it's more silence. There is no there is no safety issues, comparing to the combustion one.
Okay, bro. I think maybe this is the last questions. Okay, it's from the Facebook actually. Okay, so we've been talking about the good things about hydrogen from start. Okay, and looking at every technology, there's always a good and bad things. So, is there anything that hidden, risk associated to hydrogen application for energy? Based on your opinion.
The hidden agenda.
Any risk, okay, maybe any impact in the long term, because any technology there's always a plus and minus.
Yes, the issue is safety, the safety factor of the hydrogen, and the LCA, the circular economy. That's now the problem of the how we can create the hydrogen society, and we need more attention on the infrastructure. We need more finance on the infrastructure. But learning from the Japan movement, I saw from the around 2000 until now, they're really aggressive, and they have so much funding to make the implementation of hydrogen. And luckily, the price inside those that country, the Japan country, it's much more higher than abroad. So as for example, they imported the liquid hydrogen from Australia, which is, it looks so expensive, but no, the answer of Mitsubishi that doing that is no, that is the economic feasible for us, because the price inside the Japan is much more higher, and they want to import also the much more ammonia from Indonesia. I think the Brunei near us, Brunei already export also methyl cyclohexane, right? In last year, in the pandemic season, they announced us that methyl cyclohexane have been imported, have been exported to Japan firstly, and but that not the green one, okay, that's the gray one. But the economic happened, and they used to burn to supply the transportation, to supply to the grid and so on. And I think Japan have a unique condition. That's why the hydrogen could be implemented. And I think that that experience not just implemented in even in Indonesia or in Malaysia. We must thinking about our resources, because yeah, the hydrogen could be created from everywhere, from many resources. Then we must think about the implementation. As I mentioned you about the remote area, this is a specific isolated island, but we can implement it fuel cell over there and match the economically feasible, because an isolated area, the price of the electricity in Indonesia is different from the Java Island. The Java Island is so, well, it's common price. This is only 70 cents per kilowatt hours, and then at the isolated area would be more than $1, yeah. No 1,300, it's no, I'm sorry, 7 cent comparing to the 13 cent. So the hidden well, I think the management of risk would be the important things if we implement it in the specific area, because not all over the people know about the fuel cells, know about the hydrogen. It must should be educated first, and then I think well, step by step, we must educate the people. And even with the using of the photovoltaic now, there is in specific island that the people right there didn't know about the photovoltaic itself. It must struggle to explain the fuel cells and hydrogen. So I think the near term and the near years, we just starting to make a feasibility study of the hydrogen inside the Indonesia, but hopefully the implementation in Southeast Asia, including Malaysia, Singapore, and Brunei would be increased.
Okay, Prof. I think we have taken a lot of your time. Okay, it's already almost 4 o'clock Indonesian time. Okay, and I think about 90 minutes you have spare with us. So I think today I learned a lot. Okay, especially on the movement in Indonesia. Indeed, there's no single solution for our way to achieve a net zero emission, and hydrogen is one way to go. Right. So on behalf of all the audience today, I'd like to thank you, okay, for sparing your time. And on behalf of the UKM-YSD Chair for Sustainability, also I'll thank you for your time as well. So to all the audience, okay, please maybe can open your camera so we take one photo together, okay, and as a Noha, please help.
Okay, please open your camera.
Okay, please open your camera, everyone. Okay. Yeah.
All of the audience is from UKM?
No, Prof. We have a Prof. Peter from Netherlands, and then just now there's an audience from Qatar as well. And then,
nice to know it.
Yeah, so it's open for everyone, Prof. Yeah. I think Encik Iqmal from Tabung Haji, and we have from Sarawak Energy as well. So it's a wide range of audience. Yeah. Okay. Noha, okay?
Kita tunggu kejap Ada yang tak buka lagi.
Baru. Okay.
Okay, ready. 1, 2, 3, smile. Okay, freestyle. 1, 2, 3. Okay, thank you.
Okay, thank you so much. Okay, so to know more about our events, so please follow our social media. Okay, until then, so thank you to Prof. Eniya, thank you to all the audience. Have a nice day. Okay, and see you soon.
Thank you, Mr. Mohamed. Thank you so much all the members
thank you, Prof.
here. Hopefully, I can go to Malaysia and September.
You're always welcome.
Yes.
You're always welcome.
Thank you.
The conference is also one of the committee, and actually I joined the Yogyakarta one when I was a student.
Oh, that's good to know. Let me know if you go to Indonesia also.
Soon. Maybe for ABBS, I'll try to come in Indonesia.
Okay, that's good. Okay, nice to have you here, all of the members. Have a good time.
Prof.
Yeah, thank you so much. Assalamualaikum.
Waalaikumsalam, Prof.
Tu dekat dalam grup ada.